Ever wonder how AI models like ChatGPT tackle brand new tasks just by seeing a few examples? It's not magic, it's in-context learning, a phenomenon that reveals how these systems balance memory and pattern recognition. Let's unpack the science behind it and discover how models decide whether to memorize details or generalize patterns. Imagine training a student to solve math problems. If they encounter a mix of algebra and geometry, they might memorize formulas for algebraic equations, but apply logical reasoning to geometric proofs. Language models do something strikingly similar. During training, they're exposed to a mixture of tasks, forcing them to switch between two core strategies. 1. Memorizing, treating each task as a unique puzzle. Think of it as a student who commits specific answers to memory. 2. Generalizing, identifying underlying patterns across tasks, like a student who grasps concepts to solve novel problems. But why does a model choose one approach over the other? A groundbreaking study reveals the answer lies in a critical trade-off: the balance between how well a strategy fits the data, measured by loss, and how complex the strategy is, measured by complexity. It's like a chef weighing flavor, performance, against simplicity, efficiency. Here's the key insight. As models face more diverse tasks, their strategy shift isn't linear, it's superlinear. That means the transition from generalizing to memorizing accelerates faster than expected. Imagine a student confronted with 100 distinct subjects. Instead of trying to understand overarching principles, they suddenly abandon abstraction for rote memorization. To explain this, researchers developed a hierarchical Bayesian framework, a mathematical model acting as a decision-making tree. It lets the model evaluate the likelihood of each strategy based on incoming data. Pre-training is like the model building a prior belief about which strategies work best, while inference-time behavior involves averaging these strategies, weighted by their probability. But why would a model ever favor a simpler strategy that doesn't generalize? The answer lies in computational constraints. If a model's architecture is too complex, it risks overfitting, memorizing noise, or getting stuck in local optima. The study shows models prioritize strategies that balance performance with efficiency, like a chef choosing a recipe that's both delicious and quick to prepare. This framework isn't just theoretical. It predicts model behavior without inspecting internal weights, a major leap in AI interpretability. It also explains why models sometimes forget to generalize as training progresses, shedding light on the interplay between data, architecture, and optimization. So what's the big picture? Language models aren't just clever algorithms. They're rational learners, adapting strategies like humans do, balancing simplicity, data, and constraints. This research paves the way for smarter AI that learns faster, adapts better, and maybe even thinks more like us. Thanks for watching, stay curious, and we'll dive deeper into the mysteries of AI next time.